Hello everyone, we are starting a free open lecture on our Discord right now. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and get answers in an online format, join our online lectures. You can find the link to our Discord in our Telegram channel. To find out the lecture times, join our Telegram channel. Today, we will be solving problem 2600. We are given 3 seconds and 256 megabytes of memory for the data structure called torcoder. What do we need to do? We are given a string S which contains n lowercase letters of the Latin alphabet, and then there are m queries. Each query is characterized by a pair of integers, elite and erite. Here the numbering goes from 1 to n. Accordingly, EL will also have a minimum value there, not 0. And what do we need to do when responding to a query? So we have these additional queries, and what do we need to do next? We need to change the characters in our string S on the specific segment from LDR inclusive in such a way that the particular substring from LDR becomes a palindrome. And if we have several such permutation options, we need to make sure that this palindrome is lexicographically the smallest. And if we cannot make a palindrome from that subsequence of characters, we do nothing in any way. We simply ignore that query. Well, there's nothing much more here. So in the end, when we receive a query, we execute all these queries. And in the end, we just need to output the string that results after processing all these queries. This will be the answer. The limit is 10 to the power of 5. This applies to both the length of the string and the number of queries. All letters are lowercase Latin, and there for LR it is guaranteed that R is greater than or equal to L, so all segments are correct. Well, we can go ahead and look at the first test example right away. What do we need to do here? Here we have a string called abba. We get abshba. This is 1, 2, 3, 4, 5, 6, 7. And what do we need to do? Like for example, here is the first query from 1, 3. This means that we need to make the substring abgba from it, a palindrome. Well, the only way to make it a palindrome is to get ABA. So we will write that down. We will leave the rest unchanged. The second query is 5.7. We take the substring 5.7 and also make it a palindrome. Here, accordingly, there is only one way to make it a palindrome, ABAC, and here too, it will become ABA. Here we have processed all the queries thoroughly, and this is the resulting string that we got. A BAC ABA, and here it is in the answer the same thing, well, not the same thing. A simpler example, the string ABC means we have, for example, specifically in this case, C1, 2, 3. The first query we take. The substring 1, 2 from this substring we cannot make a palindrome in any way, so it remains as it is, and we take the substring 2, 3 from it. We also cannot make a palindrome. We ignore it, and, as a result, we get the same string as it was. And here is ABC. That's the kind of problem it is.
Want to become a great programmer? Subscribe to our Telegram channel.
Well, let's move on. Actually, if the constraint here were 10 times smaller, this problem could be solved naively in n times f, but here it's 10 to the power of 5, so we need to think of something. And before finding the correct solution, we need to consider the basic solution, which runs in n times m and does not meet the complexity requirements here. What would we do? We would honestly take this segment, take some substring from it, and try to make a palindrome out of it. And here the first question arises. We have some string. Well, let's say AB. Here it is. How can we make it a palindrome? That is, how do we need to rearrange the characters to form a palindrome? But before answering this question, we need to answer one more question. Is it even possible to make a palindrome? And this is our first question. This is the second question. Here we have the string AB. Why can we make a palindrome out of it? We have one odd letter here, and indeed the letter A actually has an even count. In fact, it is quite interesting, remarkably. Then let's just see what is in a palindrome. Just a little bit more. Well, if the length of the string is definitely less than or equal to 1, then it is 100% a palindrome. Because either the string is empty, which is a palindrome, or the string consists of a single character, which is also a palindrome. So next, we proceed with the division. The first division is when the length of the string is even, and the second is when the length of the string is odd, specifically in particular. Well, let's first consider if the length of the string is even, then what? For example, let's say we have AA, BC. The length of the string is even. Can this string be made into a palindrome? No, it cannot, because we have two A characters, one B character, and one C character, which makes it impossible to rearrange the string into a palindrome. A palindrome requires characters to be symmetric, and we can simply place A on the edges, and here we will just have B and C, basically, well, or the other way around, and it is no longer a palindrome. Accordingly, from this we can draw a conclusion. If the length of the string is even, then the count of characters in this string, the count of each and every letter in this string, must indeed also be even. In this string, for example, if I had BB here, then we could already make a palindrome out of this string because the count of each character in this string is even, and we can make a palindrome like BABA or BAAB. Okay, now if the length of the string is odd, for example, we can take something like AAB, so the length is odd. For instance, if I had BB here, then we could already make a palindrome out of this string because the count of each character in this string is even, and we can make a palindrome like BABA or BAAB. Okay, now if the length of the string is odd, for example, we can take something like AAB, so the length is odd. In our collection, we have exactly two characters that are the letter A, and in addition to that, we also have a single character that is the letter B. And so if we can make a palindrome from this string, it will be in essence AB, and for example, an odd number of A, B, C, which characters are present, such as A, B, and C. In my collection, I possess a single A, a single B, and a single C, each of which is unique and distinct. But I cannot make a palindrome out of this string. Why? Because I have more than one letter here that appears an odd number of times. That is another conclusion for odd length strings. We end up with only one letter. A character can appear an odd number of times, and then we can make a palindrome from this letter. Otherwise, it won't work. So, in general, we have answered our first question on how to determine if a given string can be made into a palindrome. To reiterate, if we have a string of length, well, it doesn't even make sense to separate it into something else because it either fits here or there. If indeed we have a string of length 0, then each individual character appears 0 times, and 0 is an even number. If, however, we have instead a string of length 1, then there is only one single individual character, which means it's odd. Accordingly, this also fits here. Then, if we have an even string, essentially each character must be even. And if we have an odd length string, then only one character can have an odd count of occurrences. All others must be even.
Want to become a great programmer? Subscribe to our Telegram channel.